everyone, welcome back to the session on fundamentals of computers. We were discussing the third unit, that is the components of computer, the hardware components of computer. In the morning session we were discussing about the different types of output devices we have, the printers, monitors, and then the other voice recognition systems. So after that, the second part in your hardware components is that in the third unit we have to discuss about hardware components. We all know what is the difference between hardware and software. So what is the computer hardware? It is a collection of physical elements that constitute a computer system. Computer hardware refers to the physical components or component of a computer such as monitor, keyboard, computer data storage, hard drive disk, mouse, system unit, graphic cards, and sound cards, memory, motherboard, and chips, etc. All of which are physical objects that you can actually touch. So what do you mean by as computer hardware? Generally we know some of the components here: monitor, keyboard, computer data storage, that is your secondary storage, you can consider the physical memory that you have, and then hard drive disk. What is a hard drive disk? It's your secondary storage. And then we have mouse, which you know, and the system unit. What do you have in system unit? The graphic cards, sound cards, memory, motherboard, and chips. Okay, all of this which are physical objects that you can actually touch. All these come under computer hardware. Computer hardwares are broadly divided into 4 types. Okay, what are those 4 types? They are input devices, output devices, storage devices, system unit. So we have 4 types of computer hardwares, that is input device, output device, storage unit, and system unit. We have already seen that block diagram previously, in which we were able to understand the differentiation. In the input devices, what do you have? The hardware used to input data into computer system like keyboard, mouse. Okay, they are your input devices. Output device, hardware used to output process data from computer system like monitor, printer, they are all output devices. What do you mean by storage devices? Hardware used to store the data like hard disk, pen drive, CD, etc. Okay, and system unit, it all deals with your CPU, motherboard, graphic card, data bus, system cables, ports, etc. I will show you the diagrams of all these components, so you need not worry about it. And so now we know what are the 4 different kinds of hardware components we have, and what is the computer hardware, what do you mean by computer hardware. And then if you see here, will you be able to label all the computer hardware components that are available here? Starting from 1 to 10, what are the different components we have? We all know this much about a computer, and inside the CPU generally everyone knows about motherboard, disk tray, hard disk, and all. But generally when you talk about motherboard, people will only be able to talk about the motherboard as a whole. But do you actually know what is there inside a motherboard? We'll be dealing with all of them in today's session, where I'll tell you what are the different components that we have in a motherboard. Okay, before going to that, let's discuss about computer software also. What do you mean by computer software? Computer software is a set of programs, procedures, code, and related data that provide the instructions for telling computer hardware what to do and how to do it. In the first sessions from the starting sessions onwards, we were only discussing about the same concept, where we only have the hardware layer which doesn't know anything, and we have to program them and send them instructions accordingly, so that the hardware will understand what to do and how to do. Okay, based on the efficient code we write, and based on the capability of the hardware, there will be a output that is that we get as a user. Okay, now softwares are broadly divided into 2 types. What are those 2 types? System software and application software. What do you mean by system software? System software is any computer software that manages and controls computer hardware so that application software can perform a task. Operating systems are the best example for system software, because they are the softwares which are being processing all the information for us, all the tasks they are performing, and also they are processing the programs that are required. Now operating systems such as Microsoft Windows, Mac OS X, or Linux are prominent examples of a system software. So we all know what kind of system softwares we have, because we all have been using them, but maybe some of us don't know that they come under system software. Okay, and then application software. Application Application software are programs that enable the end user to perform specific productive tasks such as MS Word for word processing or Photoshop for image manipulation. So whatever applications that we are using, previously we were discussing more about MS Word for word processing or data processing, and I was giving you so many examples related to MS Word, PowerPoint and all. So all these softwares are an example of your application software. So you can see the images of your system software here. You have your Windows 7, Windows 2003, Windows XP, and your application softwares, that is Microsoft Office, Adobe Photoshop and all. Okay. So the hardware and software have a symbiotic relationship. This means that without software, hardware is very limited, and without hardware, software wouldn't be able to run at all. They need each other to fulfill their potential. So without one, the other will not be efficient in performing the operations that are required. Okay. And then what are the types and components of computer systems? Let's try to understand what are the different types and components that are there in the computer system. So we'll be having a difference between computer software and application software. First of all, so the system software is on this side and the application software is on that side. When you consider the usage, the system software enables the computer to function, whereas the application software, it enables the user to work efficiently with documentation. Okay. So the system without the system software, you cannot run the application software. That is the first thing. And even if you only have the system software and if you don't have the application software, then also you won't be able to get that required task done. So these two are very much important and required in order to complete a task for the user. Okay, specific task for the user. So what is the need? Need means the system software is important and it's very much required for the hardware to function as well as for the user to install something. So this is very much important and it's compulsory, whereas it depends on the usage of the need. Suppose if the user is only using MS Word and it doesn't require PowerPoint, so PowerPoint is another application software which may be required based on the usage, but if we don't require or if we don't need to create some PPTs, then we don't require that PowerPoint software. So all application softwares are not compulsory and they are only optional based on the need and it depends on the usage of the user. Okay. And then when you see the number of softwares, each computer needs one system software. Okay, whereas each computer can have more than one application software. Generally whatever operating systems that you are using, they are all only one kind. Like in the Windows, you are performing all the application softwares and their tasks, but you are not installing 2-3 system softwares and you are working on them continuously. But whereas application softwares, you have so many kinds of application software installed in your computer and you work with them accordingly. And then dependency. What do you mean by dependency? These system softwares are independent, can use without application software, whereas this application software, it's very much dependent on your system software. Without system software or application software cannot work without, there is a mistake actually, they are dependent. That means they cannot work without system software. Okay, application softwares cannot work without system software. And then function. What is the function of the system software? They provide environment in which the applications run, whereas they provide the environment to enable the user to accomplish the specific task. That means in the system software, the application, the operating system or the system software, it's providing an environment on which we are able to create new applications, and these applications are being used by the user for their individual or required tasks. And then, so first we understood what is the difference between system software and application software. Next we will try to understand the difference between hardware and software. Okay, so what do you mean by hardware and what do you mean by software? Software is a set of instructions that tells a computer exactly what to do, whereas hardware is physical part computer that causes processing of data. Okay. Software cannot be executed without hardware. Hardware cannot perform any task without software. Even if you have the hardware and if you don't have the required software to work, then it is of no use having that. The same way, if you don't have the hardware, then where will you install the software? So the next thing is software cannot be touched, hardware can be seen and touched. Okay. Software is debugged in case of problem, hardware is repaired in case of problem. That means we make some changes or corrections to the code in the software or the program, whereas the hardware we replace that hardware, or otherwise we try to repair the damaged part in that hardware. Okay. Software is reinstalled if the problem is not solved, hardware is replaced. You won't reinstall, there is nothing like reinstallation, but we actually replace if the problem is not solved. Okay. So after that, what are the main components of your computer system? We have already discussed about the main components of computer system, but let's again look at them in the third unit. A computer is an electronic device, as we know, operating under the control of instructions stored in its own memory. Okay, at most basic level, a computer is a device consisting of three pieces. One is the processor, we know that CPU to interpret and execute programs, and then we have the memory, the memory unit which has primary and secondary storage units, a memory to store both data and programs, a mechanism for transferring data to and from the outside world, that is your input and your output unit. So we all know about this. The components of computer are input device, output device, system unit, storage device, communication device. Your input device, it allows you to enter the data and instructions into a computer. Output device, hardware component that conveys information to one or more people. And system unit, it contains the electronic components of the computer that are used to process the data. That means this you can consider this as your hardware component, and your input and output devices, they are the ones which are used for inputting instructions and getting the required information outside. Storage device, they hold data, instructions and information for future use. Communication device enable a computer to send and receive data, instructions and information to and from one or more computers or mobile devices. So when you see here, all of them are related to your hardware component. In the input device, you require some monitor or any other input device in order to see the you require an input device to give data to the computer. You have to feed in some programs or instructions to the computer. And how will you do that? You can directly put in a program, you can enter a program into the computer, or through the keyboard you will be able to give the input to the computer. Then the output device, hardware components that conveys information to one or more people. Wherever you want to get the output, you may get it on the screen, or otherwise you can get it as a hard copy in the printer. So these are the two different types of hardware input and output device we have. And system unit, we already know, we will see them in detail in the motherboard's concept. So the next part is system unit. What do you mean by system unit? We were talking about the system unit here, remember? So input output device, we know, we have just seen in the morning session and in the yesterday's session about the printers, monitors and all. Okay, and your input device contain scanners, keyboard and all. Okay, so we know the input and output device hardware now. Now we have to see what the system unit hardware is. So what do you mean by the system unit hardware? If you see the system unit hardware, the system unit is a case that contains electronic components of a computer used to process the data. The inside of a system unit on a desktop personal computer includes drive bay, power supply, sound card, video card, processor and memory. Let's try to understand each of them. Generally, whenever you use or whenever you see a CPU cabinet, this is not the CPU actually. Inside this CPU cabinet, you have the motherboard on which you have your processor included. Okay, so inside this box we have the CPU, that is why we call it CPU cabinet. Now along with that CPU, we have several other components which are which are helpful in performing the operations for the CPU. Now this is how you see the CPU from the outer side. When you see it in the internal components, the side view of it shows you all the components that are present in your CPU. If you see this, you will be able to identify a few of them. If you see at this point exactly, this is your hard disk and this will be your cooling fan. Okay, and behind that you have your motherboard. On the motherboard we have various other components that are included. We will see them in detail in a few minutes. Before that, over here you have your USB and you have your CD drive, and this is your processor. Where is your processor? It's always under your cooling fan, because whatever heat is that is generated by this processor, this cooling fan will always try to get rid of it and help in the efficiency of the processor. And then this is your video card. Okay. So now we know what a video card looks like, what a sound card looks like, we know this power supply, and also we know the processor and memory. You have your memory in the motherboard included, or these days we are having it outside externally. So this is how your memory looks like, and this is your processor. Okay. So now let's see the motherboard in the main circuit board of the computer system. What all do you have in the motherboard? It's a little bit complicated, but if you once try to understand how the components look like, it will be very simple for you. When you come for your offline classes, you will be able to directly see the motherboard components, and you will be able to examine them and understand them. But before that, if you just try to understand them, it will be easier for you to identify them. So the motherboard has a lot of things. Mainly the first thing that we have to talk about the motherboard is your processor. So if you see this diagram, where do you find the processor of this motherboard? Are you able to identify the processor in this motherboard? This is where you have your processor exactly located. Okay. And then over here you have your CPU fan connection, so that whatever is the heat that is being generated by the CPU, it will be able to cool it. And then below that you have your memory slots. What are these memory slots for? We were talking about the primary and secondary memory, right? You have your primary memory directly connected onto the motherboard, whereas your secondary memory is given externally. It is connected through the cable, but your primary memory is always, and in most cases, it's directly inbuilt onto the motherboard. So your motherboard has your CPU, that CPU fan, and then your memory slots for your primary memory. Along with that, you have your floppy connector here. These days we are not using floppies, but in the previous cases there was a floppy connector, so that when you attach that floppy, it will be able to read it. And then the next important thing that you have to see is heat sink. Heat sink is very important because it always tries to cool down the heat that is being generated by this processor. It always tries to correct the heat that is being generated, and it will from these components, and all that heat is being converted into that place. Okay. And then if you see these small ports here, these are the ports that we see onto the outside of the computer, where you have your input output connections, your USB connections, your Ethernet connection, and your VGA cable connection. Okay. And then you have your CD input here, where you will be able to see a small button which you click, and you will be able to open that CD drive. And then we have your IC circuits here, and then what else is important here? And then this is your CMOS battery. It will help you to understand the system state. Okay. And okay, so first of all, just try to understand these topics first, then you can go into the later parts in the next, whenever you see this for the second time, then we can go. So first time when you see this motherboard, what are the components that you have to remember? The first thing is CPU socket, then CPU fan connection, then your memory slot, then your floppy connector, then your CMOS battery, and then you have your CD input, and then you have your input output connections here, your Ethernet USB connections, and your VGA cable connections, and you also have your heat sink over there. So after this, once you have an idea about some of the components, in the second stage what you have to understand is the main important thing is PCI Express, PCI AGP. What is AGP? AGP is your graphic port. Whatever graphics that you have for your computer, they are all connected over here. Okay. And then after that, PCI, peripheral component, whatever peripherals, in the sense whatever connections that we have from our hard disk and all, whatever CD drive connections that we have, all of them have their own buses, and these are PCAs which have 40 pins, to which we will be connecting all the hard disks and the CD drive connections. Okay. And then You have your serial ports here and your connector, serial port connector is here. Along with that you have your system panel connections. So as of now just try to understand PCI Express, PCI, AGP. AGP is for graphics, and I told you about peripheral components, which is what all are the main other components that need to be connected to this motherboard. They are all connected to this PCI, and then we have our USB headers, then the system panel connections, CMOS battery, floppy generator, floppy connector, memory slots, CPU socket, and CPU fan, heatsink, and your input output connections. So if you try to understand at least this much from this diagram, it will be very useful. Okay, and then let's see about the processor. We all know what processor is. We have already discussed about the internal operations of a processor, or the different algorithms that it's using and all. So the central processing unit, CPU, is a part of the computer which interprets and executes the commands from the computer hardware and software. Whatever the commands that it gets from the computer software and hardware, it always executes and interprets them. First of all, interpreting means it will try to understand the command and then it will start executing it. Then CPUs used to be made of discrete components and numerous small integrated circuits which were combined together on one or more circuit boards. However, due to the modern manufacturing techniques, the term microprocessor, this is your microprocessor, is used instead of the CPU. This is the single integrated circuit which is at the heart of the most PCs and is also found in many household devices and equipments where some controller monitoring is needed. Example, the engine management system in the car. Okay, so the microprocessors, it is a small chip that is always making all the operations for us. This is the CPU, and this has your arithmetic logic unit and the control unit, which is able to perform all the tasks and operations for our computers. The CPU or processor have two parts, that is the arithmetic logic unit, we all know it, ALU, and the control unit. We all know what ALU and control unit does. So let's see the flow of CPU working. We all know this diagram, right, where we are having the CPU which is connected to the input output device, and this CPU is directly connected to the main memory and your secondary storage. Okay. And then for every instruction, a processor repeats a set of 4 basic operations which comprise of a machine cycle. The steps in a machine cycle are: the student enters a math problem into the memory of the computer. Then at the first step, the control unit fetches the maths problems, instructions and data from memory. Then it will convert that 100 into 48 is one problem that the student entered. So it will convert, or it will send that to the step 2. In the step 2, the control unit decodes the math problem instructions and sends the instructions and data to the ALU. The control unit is then sending it to the ALU. In step 3, the ALU performs calculations on the data. So from ALU, again, whatever is the calculated steps, it will take it, that 4800 value, 100 into 48, 4800, it will send it to step 4. At step 4, the results of the math problem are stored in the memory. Now this memory which is stored, it will then display it to the monitor. The results in memory appear on the screen of the monitor. So what are the main 4 instructions for the CPU, or the main 4 steps you have to consider? First, it has to fetch the instruction which will be used for making this calculation. Second thing, it will to decode it so that it will understand what is that it has to perform. The third thing, once it understands what it has to perform, it will then execute. Once it executed this value, it will then store it in the memory and give the display to the output. So this is how it happens, and these are the 4 main crucial instructions that are done by the CPU. So first is fetching, decoding, executing and storing. Okay, the processor contains registers that temporarily hold data and instructions. The system clock controls the timing of all computer operations. The pace of the system clock is called the clock speed and is measured in gigahertz. So generally, when you are buying a laptop or when you open your system properties, you will see the gigahertz property there, and how much the gigahertz is your computer processing speed, okay, or your clock speed. Okay. So then the next thing we have is memory. We all know what memory is. Memory consists of electronic components and store instructions waiting to be executed by the processor, data needed by those instructions and the results of processing the data. Stores 3 basic categories of items. The first thing is operating system and the other system software, application programs, data being processed and the resulting information. So these are the 3 main things that the memory unit has, and your memory is generally measured in kilobytes KB or K, or megabytes MB, gigabytes GB, or TB terabytes. So what do you mean by kilobytes KB or K? It is like 1000 bytes. So 1000 bytes in the sense the exact number will be 1024, but generally we will ignore that 24 when we compare it with 1000. So approximate number of pages of text is half, okay. And then we have megabytes MB, that is 1 million bytes. 1 million bytes means 1048576 bytes exactly when you see them. So the approximate number of pages of text that you can get from this MB is 500, okay, 500 pages. And then gigabytes, you can get around 5 lakh pages of text, that is 1 billion bytes. Terabyte, it's 1 trillion bytes, and you can get approx 50 crores, okay. The internal hard drive is the computer's main memory. This is where the application store, software, disk operating system, and data files are stored. The main advantage of these memories is the fast transfer or access and their large capacity to store data. This is okay. So this is about memory, main internal memory including RAM and ROM. We all know what this RAM memory chip looks like. This is how your RAM memory, RAM memory or your primary memory chip looks like, okay. So this is the type of memory that can be read from and written to by the processor and other devices. Programs and data are loaded into RAM from storage device such as the hard disk and remain in the RAM as long as the computer has continuous power. The system unit consists of two types of memory. One is random access memory. Random access memory is an internal chip where data is temporarily stored when running applications. This is how your RAM looks like, and it has different ICs in which it will be storing all the memory instructions or the processes that need to be done. This memory can be written into and can be read from, okay. Since its contents are lost when power to the computer is turned off, it is often referred to as volatile or temporary memory. Whenever the power is turned off, it will, all the contents inside that memory chip are disappeared, okay, they disappear. So RAM chips usually reside on a memory module and are inserted into the memory slots. Whatever the RAM chips, they usually reside on this memory module and are inserted into the memory slots, okay. There are two basic types of RAM chips existing. We have static RAM and dynamic RAM generally, okay. And then cache memory. Cache memory is something where it is like a personal assistant to your RAM, and whatever instructions it has to do or whatever data that you collect from the hard disk, the recent instructions, they are all stored in the cache memory. So whenever the CPU requires it again, immediately it will contact the cache memory, it will get the instructions or the data done, it will collect them from the cache memory and it will perform. Otherwise, if you want the recent instruction that you have performed again, it has to go to that secondary memory, fetch that data and come back. So in order to reduce that time, we are using this cache memory. And then we have read-only memory. Read-only memory is the memory used to store information that needs to be permanent. It is often used to contain, for example, configuration data of a system. These chips cannot be altered and can only be read from, hence their name. One of the main advantages is that information stored on the ROM chip is not lost even when the power is turned off. They are often referred to as non-volatile memories. Two types of ROM, that are programmable read-only memory and electronically programmable read-only memory, okay. And then, so that is about RAM and ROM. And then operating system concepts. We have already seen what is an operating system, what are the different types of operating systems we have, and we all know what user interface is: graphical user interface, command line interface. We all know these two types of interfaces. And then we have also seen the PC desktop computers that we have, laptop computers we have, the advantages we have with them and the disadvantages that we have with them. And these are the mainframe computers. This is one type of computer which is a term used for a very large, very powerful computer system. The name comes from the days when the individual computers were housed in large, often room-sized frames. See, this is how the computer looks like, and these are very powerful computers. Their main purpose is to run commercial applications such as banking and insurance, where huge amounts of data needs to be processed each day. So in order to perform so many operations in a particular day or in a single day, and it should be a continuous process, then they'll be using mainframe computers. The main features of mainframe computers are as follows: they can have several CPUs, they can have very fast processor speeds, they can support multiple operating systems, they have huge amounts of storage capacity, they have huge internal memories, example several hundred gigabytes of RAM. They are often operate using time sharing or batch processing. Okay. So, what are the advantages? Due to the features listed above, they can be used to do very large jobs which require large memories and very fast processing time. They are used in time sharing systems to allow users to be given a time slice of very powerful facilities afforded by a mainframe system. Okay. They are capable of very large number crushing, and so can deal with any varying complex mathematical functions, example fractals, which would be very time consuming using, for example, a PC. Okay. The disadvantages of mainframe computers are: mainframe computers need to be permanently housed in a large room, so they cannot be moved around. They are very expensive to operate and maintain. These are the two disadvantages, but when you compare them with the advantages, it is very much less. Okay. So, that is about the different types of computers and also the different components of hardware. In the next class, we will see about the different printer configurations that are available and the remaining parts in your unit 3. Okay. So, that is all for today. Thank you.